Welcome to the exciting world of being an ArcDroid owner. ArcDroid turns your handheld plasma cutter into a CNC robot. It's remarkably portable and includes practical features available in no other CNC machine on the market. This video will cover everything you need to know to get cutting with your new ArcDroid. To cut metal accurately with the ArcDroid, some settings will be controlled by your handheld plasma cutter and others with the ArcDroid. Before going further, we'll cover which tool controls each part of the task. Cutting factors related to your plasma cutter. A handheld plasma cutter uses a mix of high voltage electricity and air to create enough heat produced in the form of plasma to cut through metal. This is an impressive feat that comes with some variables which need to be controlled in order to achieve clean and accurate cuts. There are dozens of different handheld plasma cutters on the market, and plasma cutting is a topic in and of itself. We'll cover some of the basics, but you should familiarize yourself with the make and model of the plasma cutter you plan to use with your ArcDroid. High-frequency start plasma cutters are not compatible with ArcDroid. Keep in mind, safety is your responsibility. Be aware of the dangers of plasma cutting. You're melting steel with high-voltage electricity. Only operate according to the manufacturer's recommendations for your plasma cutter. A typical handheld plasma cutter needs 220 volts of power to create a flame hot enough to cut metal. Some plasma cutters can operate off of 120 volt, but they're limited to cutting thinner material. The electrical portion of the heat produced is controlled by the amperage, which along with air pressure produces the plasma cutting flame. The amperage and air pressure should be adjusted according to the type of metal being cut, its thickness, and the speed at which it's being cut. Cutting thicker material generally requires higher amperage and slower cutting speeds than thinner material. This is tied to the amperage rating of your plasma cutter. A plasma cutter requires a controlled, clean, and dry air supply. The air mixes with the electricity to produce plasma. Some plasma cutters have a built-in compressor, while others require a separate compressor. To cut metal effectively, a ground needs to be attached to the material being cut. Now, the height of the torch will affect the cut. If the torch is too high, it won't pierce the metal. If it's too low, it will pierce the metal with a wide and unpredictable kerf. If the torch head drags on the metal, it will put unnecessary wear on the consumables. Speed's important. Moving too quickly will mean the torch doesn't pierce the metal. Moving too slowly will result in poor edges and slag on the bottom of the material. Kerf is the width of the cutting flame. This is controlled by the size of the tip orifice of the plasma cutter combined with the amperage. You can think of kerf like the thickness of the blade of a chop saw. When you cut a 2x4 with a chop saw, the width of the saw blade is removed by the 2x4 in the form of sawdust. When you cut a piece of metal with a plasma cutter, the kerf is the amount of material removed in the process of the cutting. To cut accurate shapes, ArcDroid uses kerf compensation, which we'll cover later in this video. The torch on your handheld or CNC plasma cutter requires consumables, parts that need to be replaced from time to time. These consumables at different stages of wear can affect the accuracy of your cuts. It's a good idea to keep fresh consumables in stock so they're there when you need them. These are some of the basics of handheld plasma cutting. Again, it's worth taking time to familiarize yourself with your specific plasma cutter so you can leverage its settings appropriately with your ArcDroid. All right, let's talk about the ArcDroid. ArcDroid turns your handheld plasma cutter into a robotic or CNC plasma cutter. There are two ways you can get ArcDroid to cut a shape out of metal. One, by tracing the shape using the Simple Trace stylus and/or the built-in shape and pattern options. And two, by designing the shape in external CAD/CAM software and loading your files into ArcDroid. Whether you use the built-in operating system or external software, the same principles apply. First, ArcDroid needs to be given the shapes to cut. ArcDroid sees shapes through the industry standard file format DXF, but seeing the shape isn't enough to produce quality cuts. Where on the material do you want to make the cut? In what order should each cut be made? How fast does the torch need to move to effectively cut the material? These position and motion related details are performed by ArcDroid using the CNC programming language known as GCode. In short, DXF files represent the design of the cut, while GCode instructs the machine on how to perform the cut. Both DXF and GCode can be produced within ArcDroid, or by using external software programs such as Inkscape and Fusion 360, and then bringing them into the ArcDroid later. If you're planning to use external software to produce G-code for the ArcDroid, be sure to download the relevant post-processor from our website. There are myriad of software programs capable of producing DXF and GCode, and we're not going to cover them in this video. What we will cover are the basics of producing effective cuts within ArcDroid, including loading external files. Now let's walk through the initial setup of your ArcDroid. Here's what's included in the box. ArcDroid, Simple Trace Controller, Simple Trace Stylus, Universal Torch Mount, Calibration Triangle and brass screws, Calibration Sled, the power cable and communications cable. In addition to your ArcDroid and the included accessories, there are some items you're going to need to get started. You're obviously going to need a plasma cutter. For a growing list of compatible plasma cutters, visit the ArcDroid forum on our website. Please be aware that high-frequency start plasma cutters are not compatible with ArcDroid. You'll need consumables for your plasma cutter, a compressor with the appropriate PSI, unless your plasma cutter has a built-in compressor. We recommend 18 gauge or thicker shielded wire to connect ArcDroid to your torch head. Make sure it's sufficient for your plasma cutter. You'll need connectors for connecting ArcDroid to your plasma cutter. You'll need a USB thumb drive 32 gigabytes or less and a micro SD card 32 gigabytes or less. They both need to be formatted FAT32. These are used to update the firmware on your ArcDroid. You'll need a flat work surface and a well-ventilated space free of combustibles. Again, follow the recommendations of the manufacturer of your plasma cutter. And of course, you'll want some metal to cut. 14 gauge hot rolled steel is a good choice for getting started. Calibration, pairing ArcDroid with your plasma cutter. The included Simple Trace stylus is much thinner than a plasma torch, and plasma torch heads vary in size. For these reasons, in order to make accurate cuts, it's important to calibrate your ArcDroid. First, we'll walk through the calibration of the X and Y axis, and then we'll cover the Z axis. Leveling the machine and work surface is an important step in calibration. Without proper leveling, the process will be frustrating and will likely produce an ineffective calibration. Use the ArcDroid arm to check that the machine is level. Once leveled, clamp ArcDroid to the work surface, plug it in, and attach the controller via the included cable. Assemble the included calibration triangle. Place it within the proper grooves of the ArcDroid base and clamp it to the work surface. Connect your plasma torch head to the included torch mount. Turn on ArcDroid and tap home. Keep in mind, you must tap home every time ArcDroid is powered on. Tap the settings button and then tap calibrate. This will begin the on-screen walkthrough for calibration. Attach the Simple Trace stylus and plug in the calibration sled. Note the numbers and arrows etched into the calibration triangle. Place the calibration sled onto the calibration triangle in position 1. The calibration sled should sit firmly and glide easily along the calibration triangle. If it doesn't, you may need to adjust the 2 screws in the calibration sled. Place the stylus tip over the brass cone of the calibration sled and turn the control knob to lower the stylus tip onto the cone. Slowly and smoothly move the calibration sled along the path. Once at the end, tap Next. The screen will direct you to move the calibration sled to position 2. Raise the stylus and move the calibration sled to the next point and continue to follow the on-screen instructions. Complete the steps for position 3. Once you've completed the steps for the stylus calibration, you will be directed to remove the stylus and attach the torch head. Be sure the plasma cutter is disconnected and check that you're using a new torch tip and that it's firmly connected to the torch head. You'll be prompted to carry out the same process using the torch head. Continue to follow the on-screen instructions. When performed correctly, ArcDroid will read the result as good. Once completed, to check the accuracy of the calibration, attach the Simple Trace stylus and tap on the Trace button on the main screen. Tap the Line Draw option and move the stylus above the brass point above position 1 on the calibration triangle. Lower the stylus so it's seated on the point. Tap 0. Click the button on the stylus or on the control knob. Raise the stylus and place it onto the brass point at the end of position 2 and 3 and click. The distance of that line should measure 313 millimeters long. Following the same process, measure from the brass point between 2 and the end of 3. If the calibration is accurate, this measurement will read 313 millimeters long, give or take half a millimeter. It's best to keep the torch head in the torch mount. Removing it may require recalibration. Now we'll calibrate the Z-axis or height position of the ArcDroid. For this, you'll need a small piece of block material. Take an accurate measurement of the block. You'll need this number shortly. ArcDroid probes material and uses the slack in the cable to sense where the material is on the Z-axis. This is why it's important to allow the cable to move freely during operation. With the stylus connected to ArcDroid, tap Trace. Tap the 0 button, tap the Shapes button. Select the circle and enter the dimensions for a small circle. Tap the green check mark. Tap Settings and adjust the clearance height or clear Z to the height of the thickness block you measured. Tap the green check mark, save, exit. Tap Run. The stylus will draw the circle and end at the set clearance height. Slide your thickness block under the stylus. If it doesn't slide under, or it slides under with a gap, you'll need to adjust. Tap the settings icon, Machine Settings. Scroll down to Probe Offset and adjust the Z probe offset accordingly. You may need to perform these steps a few times until you get it right. When calibrated, the thickness block should slide freely but without a gap above the material. Your ArcDroid is now calibrated. Setting the date and time. To keep your files organized in the order they're created or loaded, it's a good idea to set the correct date and time on your ArcDroid. Just go to Settings, Date and Time, enter the correct date and time. Updating the firmware. We periodically add new features and remove bugs. Installing the latest firmware will make sure you're getting the latest and greatest of what ArcDroid has to offer. There are two updates you may need to make: the SimpleTrace operating system and the ArcDroid firmware. We'll show you how to update both. Visit our website, ArcDroidCNC.com, and navigate to the Download section to check for the most up-to-date version of both. To check your current versions on ArcDroid, go to Settings, tap the ArcDroid logo 5 times, go to Version Info. You're looking for System version at the top and Firmware version a little further down on the screen. Just check the dates and make sure they're up to date. The process for downloading and accessing the updates vary between Mac and Windows. Here's how to download and access the firmware from both a Mac and Windows system. Once you've downloaded the update files and transferred them to the appropriate device, it's now time to install them on your ArcDroid. We'll start with the thumb drive. With ArcDroid powered on, insert the thumb drive into the side of the controller and press the reset button. ArcDroid will automatically perform the update. Next, insert the microSD card into the side of the ArcDroid and press the reset button on the ArcDroid controller. ArcDroid will automatically perform the update. Connecting your plasma cutter to ArcDroid. ArcDroid needs to be able to trigger your plasma torch on and off. Some plasma cutters have a built-in CNC port, which makes it easy for the user to simply plug a cable into the unit and attach the leads from the other end into the terminals in the back of the ArcDroid. If you're using this kind of plasma cutter, follow your manufacturer's instructions for connecting to an external CNC. Pairing ArcDroid with a plasma cutter without a built-in CNC port requires splicing 2 wires in parallel with the 2 trigger cables using recommended 18-gauge shielded wire. Be aware that this kind of modification may void the warranty on your plasma cutter. Designing your workspace. ArcDroid can be operated in any number of portable configurations, on the tailgate of your truck, between 2 sawhorses, or clamped to any flat work surface even a few inches off the ground. Most ArcDroid owners will want to design a workstation that allows them to get the cuts they want efficiently, comfortably, and safely. This might mean a permanent downdraft table in the back corner of your shop, or a wheeled workbench with a water table in specific spots to place the necessary tools and your plasma cutting PPE. Designing and building a workstation for your ArcDroid can be fun and rewarding. You can find a growing list of workstation concepts on YouTube and on the ArcDroid forum on our website, but we'll briefly cover some important considerations. Your workspace should be well ventilated and free of combustibles. Keep space for the ArcDroid arm to operate freely. Consider future adjustments you might want to make, such as adding the X2, which would double the operational width required for your ArcDroid. Wheels are a great idea for portability. Consider where you'll place your plasma cutter, compressor, and the cables and hoses. Be aware that other high-voltage electrical equipment, such as a welder, when operated too close to ArcDroid, may cause your ArcDroid to malfunction. The torch cable must move freely. Some users simply hold the cable during operation, but you may decide to construct a more permanent solution. You also may decide to mount the ArcDroid controller. You can find a variety of concepts for this on YouTube. The controller screen is durable, but be aware that direct exposure to plasma cutting sparks could damage it. Now let's take a closer look at the ArcDroid controls. It's worth temporarily putting aside the plasma cutter and getting familiar with ArcDroid using the included Simple Trace stylus. Turn on ArcDroid. Remember, every time ArcDroid is powered on, you need to tap Home before you proceed to use it. First, let's talk about the physical controls. The ArcDroid arm. You can move the arm around and note the green dot on your screen mirroring the location of the point of your stylus. This dot is also present with the torch mount. The Simple Trace stylus. The Simple Trace stylus has a small button near the tip. This is used to place nodes when tracing a path and to place shapes when using the Simple Trace function. Control knob. When on the main screen, turning the knob counterclockwise will lower the torch head or stylus. Turning it clockwise will raise it. When you're using the Simple Trace function, press down on the button to place a node. This knob can also be used to adjust values in most places across the UI. With the value selected, turn the knob to adjust the value. The reset button is the small black button under the control knob. Pressing it will reboot ArcDroid. It can also be used as an emergency shutoff. The main emergency shutoff button is on the back of the ArcDroid. Press it in to shut off ArcDroid and pull it back out before turning ArcDroid back on. Now let's look at the controller screen. You can either use your finger or a fine-tipped object to navigate the screen. You can zoom in and out by sliding up and down on the left-hand side of the screen. Pan across the screen by touch sliding across the screen. There are a series of buttons on the main screen. Let's cover what they do. The orientation button is the 2 arrows under the green Run button. This button allows you to flip the screen so it matches the physical orientation of ArcDroid, your material, and where you're standing. 0. The 0 button is like placing the dumb end of a tape measure. It allows ArcDroid to know where your traced and imported files sit in relation to the torch head and the material you're cutting. This will make more sense as you start to use it, and it's worth getting familiar with. Trace. This will take you to the Simple Trace interface, where you can trace, edit, and save your Simple Trace files. Load. The Load button allows you to open files and make adjustments before bringing them into the home screen for cutting. When you save Simple Trace files, they're stored on the internal storage, or if you have a thumb drive plugged in, they'll be stored there. You can also save DXF and GCode files from a computer to the thumb drive. The Load button is how you access these files within ArcDroid. Tune allows you to adjust whether you work in inches or millimeters, the operating speed and the height of the torch head, etc. We'll cover more on this later. The Settings button gives you more options for adjusting ArcDroid, such as calibration, touchscreen, changing your file names, setting the date and time, and accessing a G-code terminal. Auto level gives ArcDroid the information needed to cut material that isn't perfectly level. It's really handy if you're on the go, you don't have time to get your work perfectly leveled. The yellow boxes on the bottom of the screen provide information on your XYZ position, feed, and units of measurement. Tapping on these elements opens the Tune interface and allows you to make adjustments to these values. Now let's talk about Simple Trace. Simple Trace is unique to ArcDroid. You can't find it anywhere else, and it's a super handy feature. The Simple Trace interface offers powerful built-in features for easily creating common shapes and tracing more complex geometry with the Simple Trace stylus. It's worth noting that although the features will be limited, you can operate ArcDroid's Simple Trace function with the torch head attached. This can be useful when making simple cuts using the shape option in the Trace UI. But for tracing more complex designs, you'll get better results with the stylus. You can also use the Trace interface and many of the following features to make adjustments to DXF and G-code files created in an external software program and then loaded into ArcDroid. Now let's look at the Trace interface. 0. Tapping the 0 button sets a reference point to establish the location of your trace or design within the cutting area. The 0 point can be changed at any time during or after tracing, and it's an important feature for placing your designs in the correct location on your material. If you want to lock the 0 point, double tap the icon. This will allow you to slide your material around under the locked torch head without moving the 0 point. The 0 point becomes really important when you want to make efficient cuts based on the amount of material you have. So if you wanted to cut multiple pieces of the same design, you could put the 0 point in the bottom left-hand corner and then lay out your design so it's covering your full sheet of metal to get a nice, efficient use of your material. Grid tools. The two icons in the top left corner turn grid snap and direction snap on and off, which is helpful when you want to create straight lines and angles. Tapping the grid settings button opens a new dialog box with additional settings, such as the size of the major and minor increments, showing or hiding the grid and references, and showing or hiding the extended cutting area. The Lines button allows you to create a free-form cut path. Each click of the stylus or control knob will add a node to the path. Double-click the stylus to complete the trace. With closed loop turned on, Simple Trace will automatically close the loop for you. Shapes. This button allows you to cut predetermined shapes. Choose your shape, move the stylus to the location you want to place that shape, and click. This will open a new dialog allowing you to change settings such as the position, the dimensions, and the cut path for that shape. Holes along a path allow you to easily place a series of holes at a chosen diameter along a set path or repeated pattern. The Transform menu provides a number of helpful features to make adjustments to your files. In this menu, you can change settings such as the position, the angle, and the scale of your file. Origin gives you options on where to place the file on your material. By default, ArcDroid will make the cuts in the same order that you trace them. The Sort button allows you to quickly change the cut order of your file. Inside to out ensures you cut out the smaller interior shapes first, which is preferred for most applications. Lead. When beginning a cut, the torch makes an initial pierce through the material, which can create a small blemish on the edge of your cut. Lead allows you to create that initial pierce at a chosen distance outside of the cut path, so you're not going to have any of those blemishes in your cuts. The blue Cut button on the bottom left determines whether the torch cuts on the inside, outside, or the center of your trace. You can also create a repeating pattern to cut multiple copies of the same design. Once you've made your trace, you can tap on the shape outline and tap Edit to make adjustments to that shape. The Undo button will allow you to undo the trace you just made. If you press and hold the Undo button, you can clear the entire screen and start a fresh trace. Tapping the Save button will save your trace as a G-code file. Press and hold the Save button if you want to save it as a DXF file. Tracing a shape. Again, you can trace shapes and convert them into cut files using ArcDroid. Use this feature to duplicate existing parts or to create shapes from scratch using a cardboard template. With the Simple Trace stylus connected, press Home. Using double-sided tape or sticky tack, secure the cardboard in place. Open the Simple Trace screen. Tap the 0 button to set the origin of the design. Turn the control knob to set the stylus at a comfortable height for tracing. Simple Trace works much like a connect the dots picture. When you click the button on the stylus or press the control knob, you're placing a dot called a node. ArcDroid moves from node to node in order to cut the shape you've traced. Depending on the complexity of the shape, you may need more or less nodes. Tracing a square, for example, would only require 4 nodes. A more complex shape will require more. When making a trace, you can either click once to add a single node or click and drag to add multiple nodes along a path. Double-click to complete your trace. Once you've completed your trace, save it and return to the main screen. Tap Run. The machine will perform a dry run of the trace. You can also perform a dry run with the torch head connected by tapping the lightning bolt in the top right-hand corner to toggle the torch head off before tapping Run. This is a super handy feature. It allows you to watch the path the cut is going to make before making the cut so you don't waste any material. So let's talk more about saving traces. Tap the Save icon to save it as a GCode file in the internal storage or to a USB thumb drive. If you want to save the file as a DXF, press and hold the Save button. You can access these save files later by tapping the Load button on the main screen. You can also open these same files in external software or other CNC machines that support DXF and GCode. Loading external files, DXF and GCode. First, let's look at a DXF file and toolpath. Here's a simple shape with a toolpath created in Adobe Illustrator. Notice the nodes along the path. This toolpath can be saved as a DXF file. When we load the DXF file into ArcDroid, we're given options to control position and motion settings. These motion-related controls are programmed using GCode. DXF provides the shape information. GCode provides the position and motion information required to cut the shape. CAD/CAM programs like Fusion 360 and AutoCAD provide the ability to not only create toolpaths, but also to predetermine the motion settings. We offer a growing number of post-processors for popular CAD/CAM programs, so you can create both the toolpaths and GCode using your favorite program. Be sure to check our website for post-processors of popular CAD/CAM programs. The Settings button opens the Tune interface, which can also be accessed via the home screen. At the top, you can toggle the units from millimeters to inches. The other settings require some experimentation to find the right combination for your specific plasma cutter and the material being cut. Feed is the speed at which the torch head moves while making the cut. Keep in mind, if movement is too fast, the torch head won't pierce the material. Too slow, and slag will accumulate on the underside of your cuts. So feed is really important. Clear Z is the height at which the torch head rises before moving to the next cut. Pierce Z is the height at which the torch makes the initial pierce into the material. Cut Z is the height at which the torch cuts. Too high and the torch won't cut the material. Too low and the edges will accumulate slag. The kerf offset value allows you to compensate for the kerf. Again, that's the width of the cut as explained earlier. Pierce delay is the time between the torch piercing the material and the start of the cutting movement. Off delay is the amount of time the torch stays in position, discharging air following the end of the cut. This helps with cooling. Let's talk about when and how to use auto level. Auto level function is useful when you're working in a portable situation and haven't had time to get ArcDroid perfectly level with the material you're cutting, or when your material isn't completely flat. ArcDroid can compensate for this by adjusting the Z-axis to maintain the cutting height along the path it's cutting. It does this by taking a reading from 3 points on the material. Tapping on the auto level button will prompt you through on-screen instructions. Creating your first cut. Now it's time to connect the torch head and make your first cut. It's good practice to clamp your material into place. Attach the ground to the material. Tap the lightning bolt so the torch head is disengaged. Turn on your compressor, turn on your plasma cutter. You can either load a file or create one. It's a good idea to start with something simple. With the torch head disabled, tap Run to observe the cut path, cut order, and the height of the torch before cutting. To avoid material waste, a dry run is always a good idea. Now go ahead, enable the torch, and make your first cut. You may need to adjust the amperage on your plasma cutter and make changes in the tune interface. Adjust these settings in between cutting small, simple shapes until you're happy with the results. You can find more tips and tricks on our YouTube channel and the ArcDroid forum on our website, ArcDroidCNC.com. Our team is always excited to see the ways in which our customers across the globe are using ArcDroid to be creative and solve meaningful problems. We're looking forward to seeing how you use your new ArcDroid.